This week we're going to be going over simple harmonic motion and waves. I apologize if I sound a little stuffy. I'm kind of sick, so I'm going to make this one a short video. I've been busy, helped out with a triathlon today. So no questions for this video, just Google all the topics and find questions. There's plenty of resources out there. There's hyperphysics, there's the physics classroom. Those are great websites that guys should all use. So let's get started. Okay, so there's a couple of new terms. Actually, more than a couple. There's a lot. So there's frequency, and that's measured in hertz, which is 1/seconds. And that's the number of cycles per second. There's the period of a wave, and that's the time per cycle. There's amplitude of a wave, which is measured in meters, and that's the displacement from the origin point. There's omega, which is the angular velocity. That's something we know. That's radians per second. Wavelength, measured in meters. Velocity, meters per second. Acceleration, meters per second squared. And displacement in meters. So what is simple harmonic motion? So simple harmonic motion is simply when an object moves back and forth in a regular pattern and the amplitude doesn't decrease. So this is the amplitude. Here's your starting point. Peak displacement is your amplitude. At the peak displacement, the object's going to have no velocity, but the acceleration acting upon it is going to be at maximum. Here you're going to have no acceleration because you're at that origin point, but the velocity is going to carry it down, and the acceleration is going to slow down and repeat into infinity. So examples are objects moving in a circle, pendulums, and objects being moved by springs. The objects being moved by springs is a big one, and so is pendulums. Pendulums have been used to calculate the gravity. You can figure out acceleration due to gravity with pendulums. It's pretty interesting. You can look up all about pendulums. The formula for the period of a pendulum is 2 pi radical L over G. That's a pretty important formula. I think I have it on a later slide. Pretty sure I do. Okay, so equations. Omega is equal to radical K over M. That's for springs. So the omega is equal to the square root of the spring constant K over the mass attached to the spring M. The distance that an object travels in one cycle is 4 times the amplitude. The peak velocity is equal to the amplitude times omega. The peak acceleration is equal to the amplitude times omega squared. The period for a pendulum is 2 pi radical L over G, like I said. And displacement, A sine omega times T. And since that's a sine function, that would be displacement from the origin point, and it'd be repeating. So it is displacement, unlike distance. So waves. So many things in nature move or propagate in the form of waves. Examples are light, sound, gravity is a new one. Scientists just proved that. Waves are just another example of harmonic motion. Except now instead of just being graph like that, you actually move like that. This sort of cyclical motion. It would be a graph, but a wave would actually be moving. So the velocity of a wave is equal to the wavelength times the frequency. And so because most things have a constant velocity, like the speed of light, the speed of sound, those are set numbers. The speed of sound is 343 meters per second in air. It's not going to be 344, it's not going to be 342. So if the wavelength increases, the frequency is going to have to decrease to keep that same speed, and that's why we say that frequency and wavelength are inversely proportional. Standing waves. So there's 3 types. There's normal, which is like on a string. there's standing waves in an open tube and standing waves in a closed tube. So first off, you're going to be asking, what the hell is a standing wave? So a standing wave is just a wave that, I'll be talking about the spring one for this example. Not spring, string. The string one. So if you take something that causes a spring to vibrate, and you vibrate the string at just the right frequency, and it's anchored on the other end, so it's anchored on both ends, the wave traveling on the spring is going to hit the end and bounce back, be reflected, and it will be opposite the original. And if you do this at just the right frequency on just the right length of rope, then you'll get what's called a standing wave, which is a series of waves through harmonic interference and the both beneficial and detrimental, you get this really cool looking wave. You can look at videos of people making standing waves. It actually looks really cool. And so the frequency of a normal standing wave is equal to n, which is the number of half wavelengths, aka harmonics, times the velocity of the wave over 2 times the length of the string. Velocity can also be equal to t, the radical t over m over L, which can also be represented as radical t over, I believe it's mu. I think that's the word for it. I don't know my Greek letters inside and out, but m over L is the mass linear density. It's the mass of the rope divided by the length of the rope. And so the frequency of an open tube, and it has to be open on both ends, is equal to F times N. It's equal to N times V over 2L. And a closed tube, where it's closed on one end, it's N times V over 4L. But you can only have odd N values. So for the second harmonic, it'd be 3 instead of 2 that you put in for N. Doppler effect. When an object is moving towards you, the wavefronts get compressed, and you generate a higher frequency sound. When it's moving away from you, so if you look, alright, so here's an object, and it's moving this way, and it's generating pulses. So as it moves, these wavefronts are going to be closer together. So like they're going to look like that, whereas as it's moving away from you, because there's the relative motion is less, they're going to be further spaced out like that. And so this means that since there's more distance between wavefronts, you'd have lower frequency here, and here you'd have a higher frequency because there's less distance between the waves. I don't think you're going to be asking questions about that on the AP exam, but you never know. And there's the formula. It's V times this, which is the speed of sound. It's 343 meters per second in air, but it depends on the material. Plus or minus the velocity of the observer. With the plus or minus, you just have to realize it's plus if the objects are going to be moving towards each other, and it's minus if the objects are going to be moving away from each other. And then the bottom, it's plus if the objects are going to be moving away from each other, and minus if they're going to be moving towards each other, times the original frequency. And an interesting thing that you can prove with this is that when an object travels the speed of sound, 343 meters per second, you're dividing by 0, so the effective frequency is infinite, and that's why you can't hear it, is because it's traveling too fast and the frequency is too high for you to be able to hear. And sound intensity. So the measure of how loud a sound is measured in decibels. And the decibels are a logarithmic unit, and the formula is 10 times the logarithm of base 10 log of the intensity of the sound over the intensity I naught, which is what's called the threshold of hearing. It's equal to 10 to the negative 12th. And because you're dividing by I and I naught, and those have the same units, decibels are unitless. So that's everything for this week. No questions. Sorry, I just feel really bad. Well, no, this was the last video. It's been good making these. I hope you learned a lot from them. If you're prepping right now for the AP exam, the only thing I can tell you is practice, practice, practice. There's only 2 ways to get good at physics, and if you don't have one way, which is you just intuitively understand it, there's only one way for you, and that's practice, 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 and more practice until you practice so much that you intuitively understand the problems and say, oh, I did a problem like that before. That's my tip to you. Don't stress about the exam. And yeah, that's it. Alright, last video.